Good day, everyone. I am Christine, the moderator for this webinar. I welcome everyone to today's webinar, that is 101 Human Error Reduction in GMP Manufacturing Floor. I would like to introduce our presenter for today, Jeanette Colazo. Jeanette Colazo, PhD, is an industrial organizational psychologist with over 20 years of experience specializing in engineering psychology and human reliability. So I would now like to hand over the floor to the speaker. Over to you, Jeanette.
Thank you so much for the introduction and welcome everyone to today's webinar. Like it was mentioned, my name is Jeanette Colazo and I will be discussing today the topic on human error reduction in GMP or regulated environments, because at the end of the day, it works for any type of regulated environment. But we're going to be focusing on GMP and we're going to talk about some of the regulatory requirements of the whole human error reduction program, human error investigation, corrective actions, the preventive actions, CAPA effectiveness. We're going to see the whole process from the very beginning all the way to measuring CAPA effectiveness. So we're going to talk about the psychology of error. We're going to talk about the tools that we use for root cause determination, and then we're going to put it all together, all right? First, I want to start, of course, with regulations. Now, the European GMP goes a little further and provides you with a little bit or a lot more details and granularity. So why talk about human error? Well, today is the major contributor for non-conformances, unplanned downtime. It impacts productivity, our key performance indicators, OE, cycle time, customer service, and also regulatory standing. So the challenge that you are going to have, and now let's talk about training so we can get that out of the pitch. Human error, we know that if the person has been trained, qualified, they have everything. If we miss something, okay, so human performance, your job is to design errors out. To err is human, to forgive is a good design. Part of what we have to do in order to go and direct our actions towards the right direction is to start moving away from that old paradigm, that old vision on human error in which we would blame people for everything. No, people come to work because they want to do a good job around us that affects our performance, okay? So when we talk about human performance, what affects our performance? So we can start working with those facts, all right? So now, what are the type of errors that we are going to be working on avoiding? If you want to use AI, and this is just to give you an idea, you can use Copilot. These are the definition, all right? So for example, operators decided to skip a step to save time, This is the answer. This will be classified as both. Continuing to talk about human error, let's talk about the common causes so we can pay special attention to this type these type of issues. We looked and we found and we put together a methodology, that's the one that we are going to learn now, which have the best practices of everything that we have learned in human error solutions through all this time. Let's take a look at some of the data that you can find if you were interested. This is another piece of information. In this case, what we're seeing is the effect. We are all going to make mistakes. I think at this point, we do understand all of this. We're going to have to clarify expectations. We will make mistakes. It's part of our nature. And sadly, in GMP environments, so what can we do? Still, we can do other things, of course, because not all the time we can eliminate the human interaction. So how do we do this? Well, this is an example of our investigation process. The investigation process basically starts with an interview. Then you have to do a walkthrough. Then you evaluate their documents. Then you take a look at the equipment. And then all of that is put together because everything affects performance. So we have different tools that we use for this. You're going to see there, in this case, we have RCDT, which is root cause determination tool. We have CL, which is cognitive load tool. Now, we want to move away from the blame cycle because people lose trust, and we need people to tell us what's happening so we can fix it. So be careful with the blame cycle. Answer what happened, how it happened, when it happened, where in the process did it happen, who was involved, and then why, so we can correct, prevent, predict, and control. So the model that we use for investigation, it's a five-wide process, a document that has 100% of the root causes for human error. It was originally developed by the Department of Energy of the United States, and what we did in human error solutions was to adapt to GMP environments. And in systems, well, we have some policies, risk management, those are the categories. And then we have individual performance, which is a totally different, this is the tool. Like I said, every single human error root cause is here. First of all, this tool is almost self-explanatory to the root cause. At this point, we're applying almost nanotechnologies, and the categories for cognitive load are these 10 categories. Correction, fix and not repeat. Prevention, fix and before it manifests. And in conclusion, if it's a lack of training, train. If it's an honest mistake, coach. If it's asking the impossible, adjust expectation. And if the person knew better, hold accountable. That's basically my presentation. Well, thank you so much for the attention.
Thank you, Jeanette. That concludes the session. Thank you everyone for participating. You may all disconnect now and have a great day ahead.